Hi, I'm Jim Van Dam. I'm the Vice President of Customer Experience here at NLB Corporation, and welcome to this newest edition of our Tech Tip videos. Today I'm joined by Anthony Wojciechowski. Anthony, tell us a little bit about yourself.
Sure. I've been with NLB for 17 years. I started in 2008 in the R&D department. I designed all of these RPNs that we're going to talk about today.
Let's talk a little bit about what they do. Before we get into the specifics about the tools, let's talk about why we made them. These are specifically designed to clean pipes and tubes. Specifically, these are tubes, smaller. And for years, it's been an issue, right? In different processes, companies are putting things through tubes and pipes. Eventually, those things build up or block off, and you need a way to get them out. High pressure water has been one of the preferred methods for well over 50 years. In the beginning, they would take something like a drilled nozzle, put it on the end of a flex lance, and try to push that through. That really wasn't rotating anything, although they might try to move the flex lance back and forth. So NLB's next generation of tools would have been the RPNs?
The RLM.
The RLM, okay. So tell us a little bit about what the RLM was.
Sure. The RLM is a lot like a fixed nozzle on the end of a flex lance, except we put a rotating barrel on it. So at the end of the tool would be a nozzle, which doesn't rotate, and then there's a barrel in the middle that has jets that point straight out to the side. And that's more for removing scale and polishing a tube. It doesn't really do a good job of cutting through debris that's plugged in a tube.
Okay. So in the beginning, there was a nozzle that had no rotation. The next generation was a nozzle that didn't rotate in the front, but it had rotating jets that would polish the ID of a tube.
Correct.
So in 2008, 2009, NLB started to work to develop the Typhoon nozzles. And what is different about a Typhoon nozzle from what had existed previously at NLB?
Sure. I will take that there. The Typhoon nozzle actually has a shaft that rotates. So when we put a nozzle on the end of this, that nozzle has offset jets that will drive a rotation. And this is a very simple part, although very tight clearances, because we use a water bearing to spin this. You can't fit bearings and a brake and everything inside of a tool this small.
Right, there's not much there.
Right, so we actually use the water. We actually use a little bit of leakage water to lubricate.
It's a water bearing.
To act as a bearing, yeah. But what that allows is that allows a fixed hose on the end or a fixed flex lance and then a rotating nozzle. So if a tube is plugged, there's no longer a need for an operator to manipulate a lance around. It just rotates and they can just push.
Okay, so not only is there rotation that's cleaning the ID, there's also a rotating jet or jets in the front that can force itself through blockages.
Correct.
All right. So let's talk then about the nozzles that are available. For most of these, there are 3 versions of nozzle tips that can go onto the nozzle body. What are the differences between these nozzle options?
Yes. So the first one is a polishing nozzle, which is similar to what the RLM does. It has jets that point out at the ID of the tube. So
okay.
Those jets would rotate, and that would be for cleaning scale buildup in tubes. The next one is a cutting cleaning nozzle, which has jets that point forward. We've got typically 3 jets that point forward, and then there are 2 jets that point backwards at about a 45-degree angle. And those are there to create like a pulling force to pull this nozzle into a tube so that it's not trying to push back at the operator. And they also are there to flush debris out of the tube as it's cleaning.
Right.
And then finally, the third one is a universal nozzle, which is a combination of those two. It's got jets that point forward and some that point straight out like a polishing nozzle, and then it has the jets that point back as well.
Okay, so polishing, if you really know you're going into a job and you just need to clean the ID of a tube, you'd want the polishing. If you're going to a job and you know primarily you need to cut, you'd use cutting and cleaning. If you needed a safe nozzle that could do everything, you would go with the universal and be confident that you could do almost any job you ran into.
That's correct.
Okay. And as Anthony points out, it's always important to make sure that there is more flow coming out the back of any nozzle that you put in a tube than is coming out the front, because you can have a bad day if that's not the case.
That's correct. Yeah, you don't want it to try to come out of the tube at you.
Right. You always want more water pulling it in than trying to push it out.
Correct.
So Anthony, you've been involved with these from the beginning. This was one of the projects that you started working on when you first joined NLB.
Shortly after I started here, yeah.
Right, and that would have been the 1510 and the 2410?
That's correct.
All right, well, tell us about those two nozzles.
Sure. The 2410 is sized for 10 gallons a minute total flow. That includes the leakage, and it's rated for 24,000 psi. That's the 2020, Jim.
Oh. Are you sure, Anthony?
Yeah. So the 2410 is rated for 24,000 psi, and really the shaft and the body are the same. We changed the inlet adapter to get those to rate it for those different pressures. So the inlet adapter for this would be sized for a medium pressure lance end or tube nipple on a flex lance. And then on the 1510, like I said, it's the same thing, but this would be an NPT connection for a smaller type of lance.
Right, so for users that aren't real familiar with high pressure water connections, 15,000 PSI and below, depending on the size of the thread, that's an NPT, which is a tapered thread, and you can use that at pressures up to 15,000 PSI.
Correct.
Once you get above that, you're starting to use connections that are cones, where instead of the threads actually sealing the high pressure water, you have two cone surfaces that are pushed together, and that's where the sealing happens.
I do want to mention too, as far as the nozzle options, as I said, the shaft and the body are the same. The difference in the nozzles is just in the size of the orifice that's drilled. So you can put any 15,000 PSI nozzle on a 2410. The problem is that you'll have too much flow rate. You won't be able to make pressure. There'll be too much pressure drop. So we try to size the nozzles so that they're optimized for that 10 gallons a minute flow.
All right. So you really want to, if you have a 1510 and a 2410, you want to make sure you keep those nozzles separate and you know which one goes on which body, or you're not going to make pressure.
Correct. Or the other thing you can do is if you have a 1510 and you don't quite want to flow 10 gallons a minute, if you put the 24,000 PSI nozzle on, the flow rate will come down a little bit, so you don't have the pump to necessarily run that nozzle.
Okay, that's interesting. Good to know. So after the 2410 and the 1510, what were the next versions that we developed?
Well, the next one we did was a 20 gallon a minute nozzle. That's this one here.
You sure it's not this one?
I'm sure, Jim.
Okay, thanks.
So the RPN 2020 is rated at 20,000 PSI, and it has a total flow of 20 gallons a minute. And then the 1520 is 15,000 PSI, obviously, and that's also 20 gallons a minute.
Okay.
And they're virtually the same as the 2410. They're just a little bit bigger body for that flow rate, and you can't clean as small of a tube with those.
Right. Okay, but you're getting a lot more flow through these.
Correct.
All right. So 10 gallon a minute, 20 gallon a minute, 24K, 15K, 20K, 15K. Which version came after those?
Oh, the next one after that was the RPN 4009, which is a 40K version for 9 gallons a minute total flow. That's this one here.
All right.
Very similar design. Some internal changes for the 40,000 PSI.
Sure.
And some tighter clearances for the water bearing.
So I noticed that for the 40,000 PSI, it looks like there's only two nozzle options.
That's correct. We have the cutting cleaning nozzle and the polishing nozzle for that. The reason that we can't do a universal nozzle with this is we actually use sapphire inserts in these, and there's just not room to keep this nozzle body this size. There's just not room to put the extra two jets in on this.
Interesting. So for 10K, 15K, 20K, you can use a drilled nozzle.
That's correct.
And you have a lot of real estate available to put those different orifice sizes.
Right.
At 40,000 PSI, you really have to use sapphires, or you're just not going to get the life out of an orifice that you need.
That's correct.
Okay. So after the 40,000 PSI, 9 gallon a minute, then we went to the smallest RPNs we ever made.
We did. We needed to clean smaller tubes, and we needed less flow rate. So we went with the RPN 2006, which is 20,000 PSI, and the RPN 1506, which is 15,000 PSI, 6 gallons a minute total flow.
Okay, 10 gallons, 20 gallons, 6 gallons, 9 gallons at 40K, and the last version that we developed was?
The RPN 4006, which is 40K, 6 gallons a minute total flow.
Okay. And that 6 gallons a minute is a kind of a magical number at 40,000 psi. That's a pump size that's been out for almost 30 years, right? That 6 gallons a minute at 40,000 psi. So it makes sense that we would have a nozzle that would run on those tools.
Yeah.
I think there's one thing our listeners probably need to learn a little bit about when we're talking about these, and that's leakage. Because in order for these to run, they have to leak some water to provide that water bearing.
Correct.
What kind of a leakage rate are we looking at as we look at these different nozzles?
It varies from size to size. We are about, I think maybe 40% leakage on the 10 gallon a minute tools, the 2410 and the 1510. We're about maybe 35% leakage on the 2020 and the 1520. Well, it's a little bit less as the pressure goes down. I should mention that. There's less leakage on the 15,000 psi than there is on the 20 because there's just less pressure to push that water through. We're only at about 25% leakage on the 2006 and the 1506.
Wow, that's impressive.
The design evolved throughout the years. That was one of the last ones we did, and so we were able to adjust the design slightly to minimize the leakage as much as possible. On the 40,000 psi nozzles, the leakage is relatively high, as you can imagine, because 40,000 psi is trying to push a lot of water through that water bearing.
Right. That's kind of the nature of the beast at 40,000 psi. If you have a leak design that you need leakage in order to get the rotation, you lose a fair amount of water through that process.
Yeah.
And that's a lot of horsepower. So it's great tools, but it's important to understand that you are losing some of your cleaning effectiveness through the leakage.
Right.
So Anthony, with a lot of NLB's tools, we are making them field repairable. Are these nozzles repairable in the field?
I would say no, but it depends on the situation. If they've been running for a while and they're simply worn out, then they're not field repairable. It would be better to just buy a new tool. If, say, you're just starting up and there's some debris in the water that stops the rotation, you could certainly take them apart and clean them and put them back together and have some success with that.
All right, and cleaning them would be, as you said, taking them apart, spraying them down with WD-40 or some kind of a light lubricant, and then putting them back together.
Correct.
All right. Are there any special tools that operators need?
We have a toolkit available for these, and it just comes with wrenches. We made special wrenches for these that are set with a square in the center of them for torquing. It's really important to not over torque these when you put them back together, because you can deform the threads and deform the inlet adapter to the body. If anything happens in there, then the shaft, the water bearing is compromised. So we have a torque rating on each one, and the tool itself has the torque listed on it as well.
All right. So you're talking about a special wrench that will grab these flats on the shaft and hold it in place for you to put the nozzles on? Gotcha.
Yep. And the same with the body and the inlet adapter. So this has flats on the back, and this one has flats on the inlet adapter.
Okay. So when you're talking about assembly, you're talking about this part of the body unscrews off. You've got your shaft, which rotates. You've got the body, and then you have this inlet adapter.
Correct.
And the inlet adapter is screwed onto the shaft?
No, the inlet adapter is just screwed into the body, and then the shaft is free to rotate in between inside of those.
All right. Is there anything that operators should do with these nozzles at the end of the day or at the end of the shift to give them a better chance of them working the next day?
Absolutely, absolutely. I would definitely blow all the water out of them with compressed air, and then spray WD-40 in and make sure to displace all the water out of them. And then after the WD-40 goes in, just give them a manual rotation to make sure everything's out and they're moving, and then they can go away in the tube.
Good. And operators or owners, if you're having an issue with these not running, one of the first things you might want to check is what the filtration system is on the unit that they're running them with, because as with any high pressure tool, it's really important that the water be clean and free of debris. And so if you have issues with these, that's the first place to look to see if there might just not be something not quite right with the water that's being used.
That's where I would look first.
Yeah. All right. Thanks a lot, Anthony. I appreciate you spending some time with us today. It's always good to talk with a person who built and designed these things. I appreciate that.
My pleasure, Jim.
Yeah, thank you. We want to let you know that we have increased our manufacturing capacity and have increased our stocking levels on all of these nozzles, all of the bodies. We're making a big push to make these available to you so that you can have them on your next job. So please call NLB up, get some of these nozzles on hand and have them ready for the next time you need to do some pipe and tube cleaning.